let's look at our next line integral example. In this problem, we are given that we're going to calculate the mass of a wire, or you could replace the word wire with a string, or maybe a cord. There are other words that could represent this. It happens to have 3 dimensions, x, y, and z. And even though this is a graph that you don't necessarily recognize, I think you should see that in the xy components we have the makings of a circle of radius 1. And then z increases over time. Z increases over time. So let me just pull out some more of the information. I have to give you a density function. I have to give you density, which I will, but I'm going to hold off for a moment. And then the line integral itself is this calculation. The mass equals line integral of the density function with respect to the arc length parameter ds. Now, it's much easier to think of this as a formula and turn your brain off and plug things in, but S refers to arc length. What we're trying to do is figure out what happens to this wire over a length with a given density function in 3 dimensions. All right, so the actual formula, density function, the calculation ds, the arc length parameter, showed was equal to the magnitude of the velocity with respect to t. All right, you should just know right now that the way I've built this is these pieces here, they do not go together. This is not a fully converted formula. This is in terms of x, y, and z, but that's clearly the variable t. This has to go. But as an in-between step, this doesn't really look like a formula either, because it doesn't really tell you what you need to calculate. So I don't have very good luck sketching this graph in 3 dimensions, but if you were to look at the top view in the x and y world, it will generate a circle once around. But as you go around this circular path, the z value is going to increase, so it's going to actually go up. What you're going to get is a graph known as a helix, or sometimes it's called a circular helix. It would look something like this if I were to draw it in 3 dimensions. You know, the 3rd dimension would come down to here, you know, x and y. But that is a horrible picture. The good news is you don't need to understand the 3rd dimensional aspect to go further. But it's such simple algebra to play with. And so if you missed it, I've actually filled in the density function here, x squared plus y squared plus z squared. And there's 2 things we have to figure out. How do we convert this to t? And then how do we build this? Well, the right half has to do with the velocity vector. And I'm going to convert back to component form because it takes less space on my paper. And that's negative sine t, and derivative sine is positive cosine t, derivative t is 1. And the magnitude of the velocity vector is the square root of sine squared t plus cosine squared t plus 1. And that's equal to 1 plus 1. That's going to be square root of 2. Constant. Kind of nice. Now look over here. Density function. Rho of x, y, z will replace x, y, and z with the x, y, and z from the path. We don't need the density at all points. We only need the density at the points on this graph. So x is cosine of t, cosine squared t. Y is sine of t. And z equals t. This is going to be 1 plus t squared. I believe I can now convert my mass into an actual integration that we can calculate. T boundaries were given to be 0 to 2 pi. If we look here, on this, my original sketchy picture here, from here to here would have been the first part of the helix. Don't even worry about trying to understand that now. Most textbooks have good examples of the helix in them. I would not call this a good example of a visual of a helix. X squared plus y squared plus z squared is 1 plus t squared, and ds is square root of 2 dt. This is not going to be difficult to integrate. The root 2 is a constant that factors. Oh my goodness, it's a single integral. I'm sort of relieved right now. The integral of 1 is t. The integral of t squared is t to the third divided by 3. And t is evaluated from 0 to 2 pi. And when the dust settles, I have root 2 multiplied by 2 pi. 2 pi cubed is actually 8 pi cubed, and then it's divided by 3. All of it minus 0, so I'm not going to show that. There are several ways of rewriting this expression, but I'm going to call this done. The mass, since no units were provided, I don't know if this is in grams, kilograms, micrograms. Since none was provided, I will put no units here either. All right, there you go.